Hey, good morning. Actually, it wasn't planned to make this video tonight. Well, actually, it's not tonight. It's 1:15 a.m. But I just wanted to give you a brief about the hand pump construction project outline for the updated hand tool project for the manufacturing engineering. So in this video, I'm going to go through this slide, and the same slide is going to be presented to you by the during the lab tutorials. And I'm going to brief here about what we need to do for this project. So the first questions we're going to build our lab report about is going to be the hand pump. So we need to ask ourselves, what is the hand operated water pump? What is the operating concept? How mostly we need the pump? Who mostly going to need this pump? And why the cost is going to be an important factor, and what is your commitments as a mechanical engineer toward those people who needing the pump at low cost. So first we're going to take a look to this photo. So it's look familiar to you. This pump has been in service for hundreds of years and still is very popular in the rural areas with the lack of the electrical power, so they still need to use the hand operated pump. It's used not only to pump the water out of the wells, but also to pump the water from the underground water reservoir, as we can see in this photo to the uh, left. Here's pointer. And actually, the reservoir is going to be filled, can be filled from tankers, can be filled from wells, but usually it's going to have fresh water, it's going to be covered, and this will protect the water from contamination due to the dust in the weather, or for example, from the heavy rains or the floods. Now, how the pump is working. All the pumps actually showing the same principle of the working. The working principle of the pump is the same, again, to have differentiate the pressure between the inlet and the outlets. So the positive displacement pump, like the one we see in this photo, we have the chamber between the two valves. As you can see here, this will be the chamber within the main bore of the pump. And the piston movement uh, going to create a cyclic positive negative pressure that causes the water displacement between the inlet and the outlet through the pump main body, or what we call the bore. So you can see as again to pull the pump shaft up, again to create a negative pressure that open the valve, the foot valve, fill the chamber, and we're going to press it down, positive pressure that open the piston valve and fill the upper side or the main body of the pump. Almost all the pumps going to have different, even different arrangement. One is going to have the same principle of the working. Well, actually, I like this one. But I think that the manufacturing process is going to be a little bit harder for you. But anyway, you can keep trying that. Even this one actually is creating the negative pressure while it's doing the movement. And we also have different designs, like for example, what we call the Dispensing Pump, which is mainly based on the using of the screw conveyor movement to move the water from one level to another. Now, in your case for this semester, you can use different models and discuss the manufacturing process of it because we're not making something in the lab. So your first task is going to be the following. As a team, you are going to select your model or models. So make a search, select the multiple models at the beginning, and then you have to do your analysis. The analysis will simply, after you're going to make the selection of 2 or 3 models, make analysis which is going to be based on the performance and the manufacturing processes of the pump parts. Then take a decision. Decision is going to be about which model you will adopt as your prime model. Which model among the 2 or 3 models you selected to be your prime model to write down the report. Next step is going to be act as an engineers. because you are engineers. Even if you are year one or year four, you are engineers. To start writing down your report, just consider that I am, or the marker is, a client, and you are engineers and you've been assigned to make a project. So you have to start first with making a sketches. Make the hand sketch for the parts and the assembly. Hand sketch is very easy. I show you this process earlier in one of the videos. Then do necessary modification for the design. If you think that it will be necessary to make this design simpler, you need to do that after having a discussion. The discussion is going to be between the team members is, can we simplify the parts to use less complicated and cost efficient manufacturing processes? This will be your discussion point to redo the parts in more simpler way, or even to resketch the parts to be more simpler. Then finalize the modify the sketches and then make the CAD parts and the assembly. This will be stage number one. Now, the stage number two, as acting as an engineer, is going to be select the materials you are going to use to make the different parts of the pump. Discuss the manufacturing processes of each part. For the materials, of course, you need to select what will be the main material you're going to use and what will be the alternative materials. Your selection of the material will be based on the specifications, the cost, and the ease of the processing. Discuss the manufacturing process of each part. Apply the DFX and come up with a conclusion. Now, the DFX is designed for manufacturing, designed for the assembly, designed for the cost, designed for the de-assembly, designed for the environment, designed for the recycling. You can have a brief of each one of these design processes in the main document of the hand pump. When you come up with a conclusion, your conclusion for the optimized manufacturing processes that result in having the pump with less cost, longer life, easier to manufacture, easier to recycle. This will be the optimum design we can have for any product. That's actually not going to be only for the pump. Use your engineering analysis sense. I expect you to do that. Use the logic. When I say logic is, for example, if I get to have the shaft, we can to make it from the road. You can have the road as already made from the steel mill. You don't have to make your own. You don't have to make, for example, the bolts and the nuts. They are offshore item. Uh, you don't do 3D printing a lot. 3D printing is good for uh, prototyping, but it's not good for manufacturing so far. Use the available technology. That means if you're going to have a machine that can do the job, you don't have to look for more advanced machine to do the same job. Okay, this will be part of the engineering sense and part of the logic is use the available technology. Also, I would like to hear your opinions because you are a team. Okay, now what do you think? How we can improve this product? How we can think about new things that make the cost less? Just put that in your discussion part. Now let's take a look to a different designs that's possible to be modified to be a hand-operated pump. We have something called the recycling pump, and this one actually is rotated. Well, usually it uses this one to pump the slurry and the material handling operation. It's operated by a motor by using the crankshaft, the crankshaft is going to be operating the piston, and the piston is going to generate the uh, differential pressure within this chamber to open the suction valve and the discharge valve. Now, can we modify this design to be operated by hand? This can be a discussion point. Another design is the rotary pump. You know, the rotary pump usually is going to be connected to a shaft. The plate is going to get connected to a shaft, and the shaft will be connected to a motor. The movement of the motor going to generate negative pressure here due to the high rotary rotation of the pump blade, and thus we're going to have the suction in this port and the compression on the other port. Can we make a hand-operated rotary pump? This can be another question. More ideas on the to select your model, your pump model. Sorry, you can see that this won't be a different design for the piston pump. The concept is going to be the same, but we're not going to have movable valve on the piston. The valve is going to be on the side. This will be the plunger pump. In the plunger pump, we're going to have the plunger to cause the positive pressure in this area by the compression down, or negative one is going to go up. The concept is going to be the same, but instead of having the piston, we should have very high tolerances between it and the main body of the pump. Simply, we can replace that with a plunger. We can make research to find the design of this type. I told you earlier about the shaftless pump. Now, the shaftless pump is only going to be a pipe which having the foot valve at the bottom. Now, you'll say this will be very easy to be designed. Yes, because we only have the foot valve, which going to be mainly a ball valve. But just remember that this is not going to be always operated by hand, bare hand. Simply, we need to add something which we call actually the tube. I forgot the name of this device anyway. I will try to find the name and send it to you. So the design is going to be mainly for the bottom valve and also for the handle, which is going to move the tube vertically to do the pumping operation. I think that many of you use the water dispensing pump. Now, the principle of this one is just generating negative pressure as we taking this one down and up. And this will pull the water, fill the chamber here by pressing is going to pump the water to the outside. Now, the problem we have with this type of the pumps is that the head is quite low. The head is how high the water can be traveled vertically during this pumping operation. Now, my question is, are there any possibility to modify this design to make it a big pump? You have to search that. Okay, so that's it. That's what we need to work on through the next 6 weeks and coming out with a report about the manufacturing processes for the hand pump. You are going to work in teams of maximum 3 students. You are going to nominate your team leader, and the team leader will simply going to assign the task on different students. For any help, you can contact me and your tutors to get the help, for example, with the critical thinking. This will be the most important thing. And also to have more experience by asking a question on the, for example, the CAD modeling of the part. You're not required to do any CAM analysis for the part or CAM processes on the part as well. So that's it. Have a good luck. And once again, just remember that for any question, we're going to be here to help you. Thank you once again.